हमारी डिस्कशंस सॉफ्टवेयर मेजरमेंट्स के हवाले से, मेजरमेंट प्रोग्राम के हवाले से हो रही हैं. एक चीज़ जो हमने भी टच नहीं की, and I would like to focus on that today, is software metrics data collection. Software measurement is only as good as the data that are collected and then analyzed. In other words, we cannot make good decisions with bad data. This is a very famous quotation from Moroni, who said that data should be collected with clear purpose in mind. Not only a clear purpose, but a clear idea as to the precise way in which they will be analyzed as to yield the desired information. It is astonishing that men who in other respects are clear-sighted will collect absolute hodgepodges of data in the blithe and uncritical belief that analysis can get something out of it. This is a very strong yet true statement about data. When we are dealing with data, when we are collecting metrics, when we are building a measurement program, we need to ask question, what constitutes good data? Measures should be well defined and valid, meaning that our measures should reflect the attributes we claim they do. But even when we have a well-defined measure that maps a real-world attribute to a formal relational system in appropriate ways, we need to ask several questions about data. The first question is, are they correct? Meaning that are data correct? Correctness means that the data are collected according to the exact rules of definition of the metric. For example, if a line of code count is supposed to include everything but comments, then a check for correctness assures us that no comments are counted. A measure of process duration is correct if time is measured from the beginning of one specified activity and ends at the completion of another specified activity. Now that was correctness. So the next question is, are data accurate? Accuracy refers to the difference between the data and the actual value. For example, time measured using an analog clock may be less accurate than time measured using a digital clock. So there is a difference between correctness and accuracy, and we need to be able to ask these questions with respect to the data we are collecting. The next question is, are they appropriately precise? What does appropriately precise means for data? Precision deals with the number of decimal places needed to express the data. For instance, activity duration need not be reported in hours, minutes, and seconds. Hours or days are usually sufficient for that purpose. Likewise, it is not necessary to calculate the mean cyclomatic number to several decimal places, since cyclomatic number expresses 1 plus the number of decisions in a module. Fractions of a decision to several decimal places are meaningless. So that was precision. Precision is also a very important part of accuracy of data, and it deals very much with the data structures. The next question that we need to ask is, are data consistent? Data should be consistent from one measuring device or person to another without large differences in value. This is important. Two evaluators should calculate the same or similar function point values from the same requirements document. इसी तरह आप किसी चीज़ की अगर लेंथ मालूम कर रहे हैं, फॉर एग्जांपल अगर किसी मॉड्यूल की लाइंस ऑफ कोड डिटरमिन करना चाहते हैं, तो दो या दो से ज़्यादा लोग अगर लाइंस ऑफ कोड के मेजर को यूज़ करते हुए उसका साइज डिटरमिन करें, तो दे शुड कम अप विद same or very similar or very close number relating to size of the data. Similarly, when same data value is computed repeatedly over time, the data should be captured in the same way. For example, we often measure the growth in size of product over time, especially during maintenance. We want to be sure that the size measure is calculated the same way each time, so that the resulting measures are comparable. और जब आप metrics की बात करते हैं, तो आपने ये data की बात करते हैं, तो obviously over a period of time you would want to compare two values. तो इसलिए it's very important to use the same units. Now, it is very important sometimes that the data be associated with a particular activity or time period. Now, another question that you need to ask with respect to data is their relationship or their association with particular activity or time period. So next question is, are they, that is data, associated with a particular activity or time period? What does it mean if they are associated? Because certain systems, data is collected at certain times or after certain activities or before certain activities. So if that is the case, then the data should be time-stamped so that we know exactly when they were collected. This association of values allows us to track trends and compare activities. Again, comparison with respect to time-stamping is very common in many systems. Another question that we need to ask with respect to data is, can they be replicated? So data are often collected to support surveys, case studies, and experiments. These investigations are frequently repeated under different circumstances, and results are compared. At the very least, project histories and study results are stored in a historical database. So line measures can be established and organizational goals are set with respect to the data that is collected. So unless the data collection from one study can be replicated on others, this amalgamation is almost impossible. So these are the questions that you must ask when you are dealing with collection of data and when you are organizing and managing and actually planning data collection. So it is very important to assess the quality of data and data collection before data collection begins. Your measurement program must specify not only what metrics to use, but also what precision is required, what activities and time periods are to be associated with data collection, and what rules govern the data collection. Especially, do you require usage of specific tools for data collection? Because many times, as we'll see later in the discussion, some of the data is collected manually, while we would want to do away with manual collection as much as possible and use tools to collect data, because that's not only easier but also more accurate. Another thing which is important is, and it's very important when you're talking about data, is the importance of definition of a metric. You need to be clear about the terminology everyone involved in the project has to understand and use the same terminology so that all involved know what is a metric and how to collect it, and then you can define times when you want to collect that. So it's very important topic that is related to collection of data is how to define the data. There are two kinds of data with which we are concerned. Number one is raw data, and number two is refined data. Raw data results from initial measurements of object of measurement, and remember, the objects of measurements are processes, products, or resources. So initially we would collect raw data, but through the refinement process, raw data are transformed into refined data by extracting essential data elements. The analysts can then derive values about those attributes, and this process is shown in the visual which I'm going to show you now. So we're looking at the role of data collection in software measurements. Data are generated by process, product, or resource objects of measurement, and they result in, after the data collection, it results in what is known as raw data. And after the collection of raw data, an extraction of useful attributes is collected or refined, shall I say, as refined data. And on the refined data, the analysis is performed, and you get what is known as derived attribute values. At the end of at the lower part of the visual, you can see that you have some direct measurement attached, direct measurements obtained from process, products, and resources, while derived attribute values, which are of interest to most analysts and most project managers, or most clients for that matter, are extracted through indirect measurements. To see the difference, you need to consider the measurement of a developer effort. You're looking at the picture, and I'm going to explain it with the help of another example. First I was explaining the picture itself, and now you can look at apply an example. The raw data effort may consist of weekly timesheets for each staff member working on a project. So, but you would want to not look at the timesheets, but you want to calculate average effort per staff member and effort per design component and so forth, which is not really available in raw data. So in order to move in that direction, we need to measure the effort expended on the design so far. So we must select relevant timesheets which were marked by designers and add up the figures. This refined data is still a direct measurement of the effort, and then we perform our analysis on it, and we may derive other indirect measures, such as the one I was referring to a little bit earlier, which include average effort per staff member or effort per design component, which these are, if you're looking at the visual, are contained in the derived attribute values. So this is the process in which data are collected from different objects of measurement, and they sort of traverse from the very crude or trivial form of raw data into refined data, and then into useful and analyzed derived attribute values. Let us now go back to defining data for collection. So the first step in this is deciding what to measure, we must specify which direct measures are needed and also which indirect measures may be derived from the direct ones that we can easily measure from different objects, including products and process and resources. Sometimes we begin with indirect measures. From, let's say, a GQM analysis, we understand that the indirect measures we want to know, and from those we would determine which direct measures are required to calculate them. And as I've said, the GQM paradigm is a very systematic approach. It basically leads us to data from the goals of from a different perspective, from a different point of view, and related to a different issue. So in that way, we are able to link our goals with the data that we collect. However, it is important to note that most organizations are different from each other, not only in terms of their business goals, but also in terms of the corporate culture, also in terms of development preferences, staff skills, and other areas. So a GQM analysis of apparently similar projects may result in different metrics at different companies, and that is exactly why we prefer GQM approach against or in comparison to a one-size-fits-all standard measurement technique. Nevertheless, most organizations share similar problems. All organizations are interested to know about quality, about cost, and about schedule. They want to improve quality, and they want to reduce cost, and they want to reduce or maintain schedules. So as a result, most developers collect metrics, information about quality, about cost and duration of different activities that they perform during the software development activities. So it is very important that whatever data are collected or metrics are collected or activities are performed, we need to be on the same page of the music, as they say. It is also important to note that no developer will be producing highest and perfect quality software in the first time. They learn, all of us learn by example, by making mistakes and by doing things, by applying the knowledge and skills that we have acquired over time. Thus, it is important for developers to measure different aspects of software quality, and that information is useful for determining how many problems have been found with a product, how effective are the prevention, detection, and removal processes. Because if you find a defect, first of all, you have to find a defect. You have to find there's a problem, then you need to solve that problem. And in the second step, you would want to prevent those defects to get into the different artifacts in the first place. So whether the product is ready for release to the next development cycle, or it is ready to be given to the customer, and you need to get information about it, and you are obviously collecting a lot of data about these things, and how the current version of the product compares in quality with previous or competing versions that are available in the software market. Now, one thing that I've said, that there has to be a consistency in terminology. There's a lot of terminology going to be used in different software projects within one company and in many companies. So I'm going to show you a visual which defines or which describes software quality terminology in some ways, and we'll talk about it when we look at the figure. You're looking at software quality terminology as a visual, as a picture. You're looking at three things. One is human error, which can lead to fault, which can lead to a failure. Now, it's very important. Sometimes we mix all of these things. We make sometimes no distinction between fault and failure, or we make no distinction between human error and fault, and things can get confusing. But it is very important to not only understand different quality terminologies, and this is one example that I'm sharing with you here, but there are multiple examples that can be quoted here. For example, a fault occurs when a human error results in a mistake on some software product. That is, the fault is the encoding of the human error. A failure, on the other hand, is the departure of a system from its required and hopefully normal behavior. Failures can be discovered both before and after the system delivery, as they can occur in testing as well as in operation. So this was one example, and you can find many of them in software engineering terminology. So we need to use and understand terminology consistently, especially those people who supply, collect, analyze, and use the data that is related to a project. For example, we need to be clearly defined what it means when you say the word fault or errors or processing errors or defects or bugs or anomalies or failures and crashes, etc. So these are things which sometimes people use interchangeably, but this can cause serious problems. Now, it is very important also that we need a clear way of describing what we do in reaction to problems. If a fault occurs, what do we do? If a failure occurs, what do we do? If a corrective action is taken, what do we do? For example, if an investigation of a failure results in the detection of a fault, then we make a change, or make one change, or make many changes in many places, because one change may affect changes in other modules and other systems and so forth to the product to remove that fault. Similarly, a change or multiple changes can also be made if a fault is detected during a review or inspection process. So there has to be a clearly defined reaction to finding a defect, and then obviously developing a removal policy, removal approach for that fault or for that defect. So whenever the problem is observed, we want to record its key elements so that we can then investigate causes and errors, and causes and issues, causes and cures for that particular fault. It is very important. That's data collection. That is the time when, one of the times when you would want to, when you want to collect data, because that is the time when you are actually looking at the code, or looking at the software, looking at the document again and doing something with it, and you're looking at it, or you're touching the document, or you're modifying the document, is caused by some factor which was residing in that document, or maybe in another document. So in particular, we would want to know about location, meaning where did the problem occur. We want to know about the timing, when did it occur. We would want to know the symptoms, what was observed, what that triggered all this detection and fixing activity, and what is the end result, meaning which consequences resulted, and the mechanism, how did it occur, how did that symptom occurred, and then what is the cause, why did it occur, if we're able to answer and analyze the product that we're looking at, and severity, how much was the user affected, and cost, how much did it cost to find and fix defects. So these are very important attributes of data collection. You cannot just ignore them. These are the things that actually lead us to what is known as defect prevention. And when organizations are mature enough to incorporate defect prevention programs and defect prevention activities in an organization, they become more mature as a result, and they spend less time in defect detection, defect removal and rework activities. तो ये वो चीज़ें हैं जिससे defect detection और defect removal और rework उसके नतीजे में ये वो एक्टिविटीज़ हैं और फिर उनको रीचेक करना कि जो हमने डिफेक्ट्स रिमूव किए हैं क्या उसके नतीजे में और डिफेक्ट्स तो नहीं हमने सिस्टम में ऐड कर लिए. दैट्स व्हाई यू हैव हर्ड द टर्म रिग्रेशन टेस्टिंग एंड सो फोर्थ. तो बात यह है कि जब आपने डाटा कलेक्ट करना है, जब आपने डाटा को मुख्तलिफ़ किस्म के डाटा को आपने कलेक्ट करना है, GQM हमें हेल्प करता है इन आइडेंटिफाइंग व्हाट मेट्रिक्स टू कलेक्ट. वी वुड वांट टू ask the question जो कि हमने पहले सेशन के शुरू में बात की थी कि about correctness, about accuracy, about precision, about their replicated nature, about their association with timing, timed activities or specific activities के साथ उनकी association. So for these, in addition to that, we also need to be consistent about the terminology क्योंकि एक आदमी ने डाटा कलेक्ट नहीं करना. Data is to be collected by a group of people, not one person, because if one person, ultimately there has to be a person in charge for collecting data, but not only one person is going to do that, it has to be a team effort. So how do we collect data? There are a number of ways you collect data. Software development, as you all know, is an intellectual activity, and the collection of data requires human observation and reporting. अगर आप as a professional आप नोट कर रहे हैं कि ये फॉल्ट आपको नज़र आती है या एक वेबसाइट है मिसाल के तौर पे और उसमें आपने स्पेलिंग मिस्टेक्स नोट की हैं कि ये स्पेलिंग मिस्टेक्स हैं उस वेबसाइट में, तो दैट इज़ अ प्रॉब्लम, दैट इज़ एन अनोमली, दैट इज़ अ डिफेक्ट. मे बी सिवेरिटी उसकी ज़्यादा नहीं है, लेकिन यू वुड वांट टू रिमूव दोज मिस्टेक्स and have a corrected version. तो सबसे पहले तो आपने ऑब्जर्व करना है कि कोई गलती है और उसको फिर आपने दुरुस्त करना है. तो जब भी आपने डिफेक्ट को नोट करना है तो उस वक्त आपने कलेक्शन करनी है ऑफ डेटा कि ये किस वक्त हुआ, क्यों इसकी कॉज थी, किस तरह ट्रिगर हुआ, एंड उसकी सिविरिटी क्या थी और उसको कॉस्ट क्या थी उसको फिक्स करने की एंड सो फोर्थ. वो 8 पैरामीटर्स हैं जिनके ऊपर हम पहले बात कर चुके हैं. So managers, system analysts, programmers, testers and users must record raw data on forms. ये जो forms हैं, this is a generic term. It is used for both manual and computer-based forms. Manual forms, वो sheets होते हैं जिसके ऊपर आप हाथ से fill करते हैं कि ये हमने data collect करना है या ये हमारी feedback है with regard to defect, ये इन points के ऊपर हमने ये mistakes note की. Computer-based forms are again of two types. One is client-server-based, the other are web-based. But still, these are forms-based. This is a manual data recording, and it unfortunately is subject to bias. It is that bias can be deliberate, that bias can be unconscious. It is still subject to errors. It is subject to forgetting or omission. It is certainly subject to delay. कि जब भी आपको वक्त मिलेगा आप उसके ऊपर डेटा कलेक्शन करेंगे, रिपोर्टिंग करेंगे. So what do you want? You want automated data capture. Therefore, because that's desirable, it is not subjected to bias. It is performed automatically. कोई delay नहीं है इसमें और कोई omission या errors का chance नहीं है if the data collection tools are good. Sometimes automated data capture is essential, such as in recording the execution time of real-time software. वो इतना उसकी speed होती है, इस तरह वो perform करता है कि manually it is not possible. Unfortunately, in many instances there is no alternative to manual data collection, so we need to ensure that the data are accurate and complete, and we must plan our collection effort before we begin to measure and to capture data. Ideally, we should keep procedures simple. जितना आपके data collection के procedures complicated होंगे, उतना data collection मुश्किल हो जाएगा. Data collection is typically in addition to their creative software engineering activities. मिसाल के तौर पे एक प्रोग्रामर है, he has to or she has to program, write programs based on the design as well as collect data. अगर आप typical mentality programmers की देखें तो they don't want to collect data because they think the procedures are very difficult and cumbersome. So we want to keep the procedures simple. We would want to avoid unnecessary recording. हर चीज़ को हर वक्त आप रिकॉर्ड नहीं कर सकते. You would only want meaningful metrics और उसके लिए हमारे पास जो बेस्ट अप्रोच है वो GQM की अप्रोच है because we are able to link metrics with goals और जिन goals को आप देखना चाहते हैं, उनको ऑब्जर्व करना चाहते हैं, उनको एवेल्युएट करना चाहते हैं, उनको सिर्फ आप उनके मुतालिक डाटा जो है वो आप कलेक्ट करते हैं. You need to provide training to staff in order for them to record data and the procedures that they want to use. Arbitrarily आप किसी को कह दें कि डाटा कलेक्ट करो, डाटा कलेक्ट कर रहा है, वो गलत कर रहा है, सही कर रहा है, जब तक आप उसको सिखाएंगे नहीं, जब तक आप फॉर्मली ट्रेन नहीं करेंगे, दैट डाटा कलेक्शन वुड बी अनरिलायबल. इसके ऊपर एक और बात भी मैं आप करूँगा थोड़ी देर में. सो यू ऑल्सो नीड टू प्रोवाइड द रिजल्ट्स of data capture and analysis to original providers promptly and in a useful form that will assist them in their work. For example, अगर एक developer है, उसने data collect किया है about memory leaks for example. Memory leaks हैं और आपने उसको collect करके आपको दे दिया है. As a manager आपने आपका फ़र्ज़ है कि you give them your feedback with the data back to the developer, उनको गाइड करने के लिए ये इश्यूज हैं, ये प्रॉब्लम्स हैं. अगर आप नहीं करेंगे तो they will lose interest. The last point in this regard is that we need to validate all data at the central collection point. This is especially important as some studies have shown that half the data collected was corrupted in some way and therefore is not useful for analysis. Lecture इस discussion के शुरू में हमने बात की थी कि आप bad data से good analysis नहीं कर सकते. So bad data obviously and ultimately results in bad analysis and bad in information. So planning for data collection involves several steps. Number one is that you must decide which products to measure. And that has to be based on your GQM analysis. Secondly, you may need to measure several products that are used together, or you may measure one part of the system of a larger application system. The GQM analysis suggests that which attributes and measures you would like to evaluate. उसके बाद जब आप एक दफ़ा एक मेजरमेंट प्रोग्राम आपने फाइनल कर लिया, फिर आपने ये डिसाइड करना है कि किन एट्रीब्यूट्स को आपने मेजर करना है और आपने जो इनडायरेक्ट मेजर्स हैं उनको किस तरह डिराइव करना है. इससे आपका जो रॉ डेटा है वो डिटर्मिन हो जाएगा एंड देन यू विल बी एबल टू कलेक्ट रॉ डेटा एंड व्हेन डू यू वांट टू कलेक्ट. तो फिर एक और बात यह है कि डायरेक्ट और इनडायरेक्ट मेजर्स को आप मेजरमेंट मॉडल के अंदर एक दूसरे के साथ रिलेट करेंगे, डिफाइनिंग हाउ मैट्रिक्स रिलेट टू वन अनदर, यानी कि दोनों के ऊपर बेस करके फिर आपने मैट्रिक्स बनाने होते हैं. समटाइम्स आप इक्वेशंस को, ग्राफ्स को और रिलेशनशिप डायग्राम्स को यूज़ करते हैं टू डिपिक्ट द वेज इन विच मैट्रिक्स आर कैलकुलेटेड और आर रिलेटेड टू ईच अदर. तो जब ये मैट्रिक्स का सेट क्लियर हो जाएगा, फिर आप उन कंपोनेंट्स को जिनको मेजर करना है वो आपने आइडेंटिफाई किए हैं, एंड यू मस्ट देन डिवाइज अ स्कीम फॉर आइडेंटिफाइंग ईच एंटिटी इन्वॉल्व्ड इन द मेजरमेंट प्रोसेस. तो आपके जैसे जैसे आगे स्टेप लेते जाएंगे क्लैरिटी आती जाएगी. यू मस्ट मेक क्लियर हाउ यू विल डिनोट प्रोडक्ट्स, versions, installations, failures, faults and other things on your data collection form. उसके बाद का जो स्टेप है वो फॉर्म डिज़ाइन करने का है, जिसमें it includes necessary and relevant information in each form. इसमें एक बड़ी important बात ये होती है, फॉर्म डिज़ाइन की एक्टिविटी रिक्वायर लॉट ऑफ क्रिएटिविटी. आपने फॉर्म को इस तरह डिज़ाइन करना होता है कि एक फ्लो के अंदर उसमें डाटा कलेक्ट हो. एंड दिस अप्लाइज टू मैनुअल फॉर्म्स एज वेल एज कंप्यूटर बेस्ड फॉर्म्स. तो फॉर्म डिज़ाइन के ऊपर बात करना apparently it looks के it is superfluous, but the fact of the matter is कि फॉर्म डिज़ाइन is one of the key areas जिससे आप न सिर्फ यूज़र का वक्त बचा सकते हैं बल्कि उसके लिए आसानी बना सकते हैं. डाटा को मसलन बहुत सारे पैरामीटर्स हैं, बहुत सारे यूनिट्स हैं, वो अगर आपने डिसाइड किया हुआ है कि हमने उन स्पेसिफिक यूनिट्स में ही कलेक्ट करना है, तो वो फॉर्म के ऊपर स्टेट कर दिए जाने चाहिए कि ये यूनिट्स हमने यूज़ करने हैं. तो फाइनली यू मस्ट एस्टैब्लिश प्रोसीजर्स फॉर हैंडलिंग द फॉर्म्स, फॉर एनालाइजिंग द डाटा एंड रिपोर्टिंग द रिजल्ट्स. पहला, चूँकि इस वक्त हम फोकस कर रहे हैं कलेक्शन के ऊपर, फॉर्म डिज़ाइन करना बहुत इम्पॉर्टेंट है. it should be very natural and intuitive when you're filling out form कि कोई fields जो हैं वो order से बाहर नहीं है. Then you need to define कि who fills the form, at what times you fill it, that is when, and where do you fill it. Is it you have to go to a specific office to fill the forms, or you can do it sitting on your computer, and you need to also describe clearly how the completed forms are to be processed. Completed forms are to be processed. अभी analysis की बात नहीं कर रहा. वो form जो है, अगर वो manual form है, let's say, तो does it sit on your table and someone else comes and picks it up after 1 week, or you have to go to a particular office to your project manager and hand it over to them, or what? I mean, that's something that जो उसकी processing है as at the end of the data collector, वो clearly defined होनी चाहिए. So in particular, you need to set up a central collection point for data forms. चाहे वो खुद जाके लें या आपसे वो collect करें या जैसे भी है, and determine who is responsible for data each step of the way. Data को, you don't want the data to disappear. You don't want this data to fall off the radar screen, क्योंकि दोबारा नहीं यह collect हो सके. Once the data has been collected and you have not kept a copy and you lose that form, then that data is lost forever. एक और बात ये कि if no one person or one group or one individual or one team has the responsibility for a given step, the data collection and analysis processes will stop, जैसा कि मैं अभी आपको बता भी रहा था. Each developer assumes that someone else is handling the data, or that's why they are not handling the data, and as a result nobody is handling the data, and the analysis and feedback will ensure that data are used and useful results will motivate staff to record the information and to collect data even in better ways next time. So ये जो feedback का concept है, this is very important. Now you cannot ask people to just provide you data on one-way system. You know, this has to be a two-way communication. Data आएगा, उसके results, उसके ऊपर analysis, उसके ऊपर feedback आपको मिलनी चाहिए, या आपका अगर management में है तो आपका फर्ज है कि आप उनको provide करें about the data. If they're collecting good data, if they're collecting perfect data, if their collection process is perfect, give them credit for that purpose and motivate them to continue to do what they're doing so nicely. Now the next question is when to collect data. Obviously this varies from project to project, but it is very important that data collection planning must begin with project planning, and carefully designed forms should be used, and you need an organization to support good measurement. सिर्फ एक आदमी या दो आदमियों के बस की बात नहीं, बल्कि you need to have a complete support system. You need to have good organization to initiate and to continue to have a good measurement program. The actual data collection takes place at many places, at many phases in development. Some data are collected at the beginning of the project, and as you proceed with the execution of the project, some more data is collected. Some data are collected when you perform reviews and inspections, and data about faults found in the inspections and reviews and tests should be recorded consistently so that you can determine the relative effectiveness of these activities fairly easily. अगर आपने टेस्टिंग की है, उसमें जो फॉल्ट्स आए हैं, उसमें जो डिफेक्ट्स आइडेंटिफाई हुए हैं, उसमें जो बग्स आपने आइडेंटिफाई किए हैं, और फिर उनको जो रिमूवल की एक्टिविटी है उनको एक तरीक के ऊपर एक टर्मिनोलॉजी में एक यूनिट्स के साथ रिकॉर्ड करना चाहिए. अदरवाइज आप कंपैरिजन नहीं कर सकते, एंड एज आई सेड कि कंपैरिजन किए बगैर आप इम्प्रूवमेंट के बारे में नहीं जान सकते. You cannot apples with oranges. You have to the same terminology. Similarly, there are about changes made to enhance the product as opposed to corrected faults. यानी कि जो enhancements हैं, जो improvements हैं कोड में, as a result of upgrades आप कह सकते हैं, not as a result of detecting faults, can be collected when enhancements are performed. और फिर उसमें आपने ये भी चीज़ देखनी होती है कि when you're performing enhancements, you're not introducing new defects. So when you're removing defects, you're not introducing new defects. So you have to be careful in that. और उसके लिए भी data collection करनी पड़ती है. And typically, what you would want to do is to collect data in the beginning of the project to establish initial baselines. Initial values of baselines बन जाती हैं, and then when those values initial baselines change, then you would want to collect data again, and this again is an on regular basis पे आपने इसको collect करना है. सिर्फ एक दफ़ा collect करके data collect करके छोड़ नहीं देना होता, बल्कि you have to do it on an ongoing basis. So it is essential that your data collection activities become part of the regular development process. ये नहीं कि एक दफ़ा काम किया and then you left and then the data becomes wrong data or bad data. It is very important that you make it a part of your development and maintenance process. Your developers on board, your designers and your requirements engineers and your testers, everybody, the entire team is on board with respect to the data that they're collecting, the measures that the products should be judged on, products, not people, and also when and how often they will be required to collect data, and what are the forms and how what should they do in terms of when they collect data, how they should report that to, how they should process the forms, and in return they are expected to get your feedback and get your analysis with regards to the collected data. It is helpful to develop and compare a model of normal development process with a list of desired measurements, and then map the measurements directly to the process model, meaning that you should in your development process model you should have the collection of data and then link your process model with your measurement program. इससे ये भी फ़ायदा होगा कि मिसाल के तौर पे आप किसी चीज़ को measure करना चाहते हैं and there is no point where data is collected, then that way you can modify your process model so that you're able to collect the relevant data. Likewise, if there is a process activity that is important and should be analyzed, then that measurement list can be appended to address it. That is, अगर आप किसी process की ऐसी activity में interested हैं जो कि आप record करना चाहते हैं, जिसके बारे में आप मज़ीद information gain करना चाहते हैं, insights gain करना चाहते हैं, या आइंदा इसको prove करना चाहते हैं, तो और वो आपकी data collection की list में नहीं है, तो this gives you an opportunity and to add them to the metrics that you would want to collect. So data collection कब की जानी है? It is basically in one short sentence. हर वक्त की जानी है. Obviously not overload people with collecting data and they're always, instead of doing their work, they're collecting data. No, that's not the intent. We need to keep the procedures simple. We need to select those metrics which we are really interested in, which are easy to collect, but they are meaningful and they're tied up to our goals. And GQM really helps in this regard. फिर जब आपने data को collect कर लेना है, फिर आपने क्या करना है? Then you have to process them, you have to submit them to the concerned people. Central repository है, you would want to keep them in a relational database. Raw data would fit in nicely. DBMS is typically a very useful automated tool for organizing, storing, and retrieving data, and it has many advantages over manual storage keeping. इस तरह एक और चीज़ ये कि हमने कहा था कि बाज़ we would want to have tools that collect data. Many times you cannot do that. You have to judge the developers, or you have to judge the engineers input, and you have to accept that. तो उसमें manual collection में बहरहाल issues होते हैं, लेकिन you have to combine both the data which is collected manually as well as data which is collected with the help of tools and software packages. इसमें एक और बात ये कि software packages are sometimes very expensive. तो ये ना हो कि आपकी जो development cost है वो इतनी ज़्यादा बढ़ जाए कि आप के लिए वो sustainable ना हो. So there are a lot of balancing things. Overall measurement program, जैसे कि मैंने पहले भी कहा था कि एक पूरी organization चाहिए measurement program को institute करने के लिए, incorporate करने के लिए in any development activity. इसका ये मतलब नहीं organization का मतलब कि आप 500 लोगों की एक company बना दें. No, the purpose is organization means a setup where you have dedicated resources, where you have people, you have funds, you have resources, you have most of importantly commitment and feedback from the higher management. तो higher management की involvement इसमें बहुत important है. Although you will not see these things discussed, लेकिन again these aspects are all part of the measurement program. So data collection is very important. Let's go back and try to think what Moroni said in 1950s about data, about the quality of data, about the need to have good data, about the need to have clearly defined goals about why we are collecting data, when we are collecting data, how we are going to store and retrieve data, and what are we going to do with data. That is, we need to not convert raw data into refined data. We need to convert refined data into derived value attributes with derived values, because that's the analysis that gives us information. So what you want to do is to convert your raw data into refined data, and that refined data into information, and when you have information you can make good decisions. Isn't that interesting? With that, I take leave of you. Thank you very much.